Hello, my dear friends. In today's lecture, we are going to discuss continuity of composite functions. We have introduced this earlier also a little bit, like we have seen that uh, a continuous function of a continuous function, it is continuous. Continuous of a discontinuous function, discontinuous function of a continuous function, or discontinuous function of a discontinuous function. In all these three cases, we can't say. We can't say directly whether given function is continuous or discontinuous. Obviously, we need to check both left-hand limit, right-hand limit, and also the functional value at that point where we are discussing continuity. So before starting the continuity of composite function, let us try to find out some limits of composite function. So here is a question for you. Fx is defined like this. Have a look at this. The definition of fx, it breaks at 0. The definition of gx, it breaks at 3. Can you tell whether this fx is continuous or not? Or if it is discontinuous, then at which point it is discontinuous? Obviously, when we see uh, when x is less than 0, the function is defined as x square minus 1, which is a polynomial function. So for x less than 0, fx is continuous everywhere. For x greater than 0, the fx is defined as x square plus 2, which is again a polynomial function. So it is continuous everywhere. What about at x is equals to 0? Obviously, at x is equals to 0, we need to check both LHL and RHL of this fx. So when we find out LHL, what it will be? For LHL, we will use first definition, x square minus 1. So at x is equals to 0, LHL, it will be minus 1. What about RHL? For RHL, we will use second definition, x square plus 2. So RHL, it will be 2. From here only, we have got that the limit at x is equals to 0 does not exist. So obviously, at x is equals to 0, fx is discontinuous. Fx is discontinuous. Let us also check the continuity of gx. So for gx, when x is less than 3, again, it is a polynomial function, x square minus 1. And for x greater than 3, it is again a polynomial function, x square minus 9. So gx is continuous for x less than 3, and gx is also continuous for x greater than 3. What about at x is equals to 3? At x is equals to 3, when we calculate LHL, we will use first definition. So it will be 8 minus 3 square minus 1. RHL, when we calculate, then it will be what? 3 square minus 9. So it will be C. Again, here also limit does not exist as LHL is not equal to RHL. So yes, GX, it is also discontinuous. Discontinuous at x is equals to 3. At x is equals to 3. So fx is continuous everywhere except at x is equals to 0, and gx is continuous everywhere at x is equals to, except at x is equals to 3. So now let us move on to first part. First part of this, we need to calculate limit x tends to 0 f of g of x. We need to find where this f of g of x is approaching when x approaches towards 0. So when x approaches towards 0, observe, my dear children, where g is approaching towards, where this function g is approaching towards. When x approaches towards 0 means which definition of gx we are going to use? We are going to use first definition. Why? Because When x approaches towards 0, either from left side or from the right side, the gx is defined as x square minus 1. So obviously we will use first definition and we will find that where g is approaching. So g is approaching towards 0 square minus 1 minus 1 minus 1. G is approaching towards minus 1. Now look at the argument of f. The argument of f is like this. F of minus 1 approaching. The argument of f is minus 1 approaching. So we will check the definition of fx. If x is approaching towards minus 1, x is approaching towards minus 1. So where fx is approaching, that we need to find. So obviously when x is approaching towards minus 1 means we need to use first definition of this fx. So yes, we will use x square minus 1. So when x is approaching towards minus 1, then fx, it will be what? It will approach towards minus 1 square minus 1, which is 0. So f, it will approach towards 0. So yes, we have got the limit of this composite function. Limit x tends to 0, f of g of x, it is what? It is 0. Have a look at this. Okay. Now, let's move on to second part. Second part is a little bit interesting. We need to find limit. Okay, let me write here only. We need to find limit x tends to 3 f of g of x. F of g of x. So when x is approaching towards 3, when x is approaching towards c, where g is approaching, that we need to check. Okay. Just look at the definition of gx. When x approaches towards 3, means when x is approaching towards 3, so gx behavior, it changes on 3 only. When we approach towards 3 from left hand side, gx is defined like this. And when we approach towards 3 from right hand side, gx is defined like this. So unlike in the above case, when x was approaching towards 0, gx was always what? Gx was always x square minus 1. But here, when x is approaching towards 3, from right hand side, gx behavior is different, and from left hand side, gx behavior is different. So we need to check both left hand limit and right hand limit at x is equals to 3. So firstly, let us check left hand limit. For left hand limit, we will write limit x tends to 3 minus f of g of x. So when x is approaching towards 3 from left hand side, where g is approaching, let us check. Obviously, g, it is defined as x square minus 1 when x is approaching towards 3 from left hand side, when x is less than 3. So yes, g, it will approach towards 3 square minus 1, which is 8. 8. Okay. Now in the argument of f, we have 8. In the argument of f, we have 8. So when x is approaching towards 8, which definition of fx we will use? Obviously, we will use second definition when x is greater than 0. So when x is approaching towards 8, this fx, it will approach towards which value? 8 square plus 2, which is 66. 66. So we have got our answer for LHL. Limit x tending towards 3 minus f of g of x. It is what? It is 66. Okay. Okay. So let us calculate right hand limit also. Let's begin with right hand limit. Limit x tending towards 3 plus, means x is approaching 3 from right hand side. So where f of g of x it is approaching, that we need to check. So when x approaches towards 3 from right hand side, means 3 plus, where g is approaching, that we need to check. So for 3 plus, we will take second definition of gx. So it will be what? It will be 3 square minus 9, which is 0. So when x approaches towards 3 from right hand side, g approaches towards 0. So in the argument of the function f, we have something like this. f0 tending. So when x approaches towards 0, where f is approaching, that we need to check. So when we look at the definition of fx, oh, f, it has problem at x is equal to 0. When x is approaching towards 0 from left hand side, its behavior is different. When x is approaching towards 0 from right hand side, its behavior is different. So again, we need to choose one definition from fx. Which definition we need to choose, that we need to check. Okay. So I write here, okay. I write here, when x approaches towards 0, fx, it is x square minus 1 when x is less than 0, and x square plus 2 when x is greater than or equal to 0. Okay. So when x approaches towards 3 from right hand side, gx, it is equals to what? Gx, it approaches towards 0. So which definition of gx we have used here? We have used first definition of gx, which is x square. Sorry. We have used second definition of gx here, which is x square minus 9. Okay. Now let us try to draw the graph of this x square minus 9. Let us try to draw the graph. Okay. Let us try to draw the graph of this gx x square minus 9. Dx is equals to x square minus 9. So the graph will be parabola opening upwards. Obviously, this point will be 9 and it has two roots. X square minus 9 has two roots. So here it will be 3 and here it will be what? Minus 3. So now let us check. When x is approaching towards 3 from positive side, from right hand side, then gx is approaching towards 0 from which side? When x is approaching towards 3 from right hand side, means like this, then gx, it will approach towards 0 from positive side or from 0 plus side. So gx, it approaches towards 0 from positive side. So now in the argument of f, we have 0 positive approaching, means approaching 0 from positive side. So now we can choose the definition of fx in which x is approaching towards 0 from positive side. So yes, we will use second definition of fx. So when x is approaching towards 0 from positive side, what will be the value of this limit? It will be 0 square plus 2, which is 2. Means f, it will oppose towards. So limit x tends to 3 plus f of g of x, it is nothing but 2. So clearly, when we have calculated LHL, we have got 66 When we have calculated RHL, we have got 2. So clearly, LHL, it is not equals to RHL. Limit does not exist. Limit does not exist. This is our answer. So this is our answer for second part. Limit, when limit x tending to t f of g of x, it does not exist. Okay. Now let us move on to last part, which is third part. Okay, I'll solve it here. Third part, when limit x tends towards 1, f of g of x, it tends towards 1. Okay, when x tends towards 1, then where g of x tends towards means when x tends towards 1, let us check the definition of g. Okay, we will use first definition of g here because we are talking about when x is less than 3. So when x tends towards 1, then g tends towards, it tends towards 0, obviously. 1 square minus 1, it is 0. Again, in the argument of f, we have 0. So again, we need to check both left-hand limit and right-hand limit here. So we will check left-hand limit first. Limit x tend towards 1 minus f of g of x. When x tends towards 1 minus, obviously, gx, it is defined as x square minus 1. So obviously, g will tend towards 0. Now, again, we need to check what is the definition of gx here. Gx, it will be defined when x tends towards 1 minus. So g, it will be defined as, obviously, it will be defined as x square minus. So again, from the graph, we need to check when g is, when x is approaching towards 1 from left-hand side, where g is approaching. We know that g is approaching towards 0, but from which side it is approaching towards 0, that we need to check. So we will draw the graph of g of x. Okay, so let's draw the graph of g of x, which is defined as x square minus 1. Obviously, again, the graph will be similar as previous one. Just we will have 1 over here, and x square minus 1, it again has two roots, 1 and minus 1. So 1 over here and minus 1 over here. Okay, so when x approaches towards 0 from, when x approaches towards 1 from left-hand side, from LHS, so from left-hand side, x is approaching towards 1. So obviously, g is approaching towards 0 from left-hand side or from negative side. So we will put minus over 0. So in the argument of f, we have what? We have f of 0 minus. So obviously, which definition we will use? We will use first definition. So using first definition, we will get f of 0 minus. It is what? It will be minus 1. So left hand limit, it is what? It is minus. Now let us check RHL, right hand limit. Limit x tends to 1 plus f of g of x. Again, when x tend towards 1 from right hand side, the gx will be, it will tend towards 0 from right hand side. Why? Because from the graph, we can clearly see when x approaches towards 0 from x approaches towards 1 from right hand side, gx it will approach towards 0 from positive side. So in the argument of f, we have f of 0 positive. So f of 0 positive means we use definition second of f. From there, we can calculate f of 0 positive, it is 2. 0 square plus 2, it is 2. Okay. So right hand limit, we have got what? 2. And left hand limit, we have got -1. Obviously, again, LHL, it is not equals to RHL. Limit does not exist. Limit does not exist. Okay. So that's how we calculate limit of composite function. I hope you are clear with it. Thank you.